Hey guys, we're gonna get started on lesson 1-4, part 1. I have the iPad out today. And then on the same formative, we'll do 1-4, part 2, which is on significant figures. So a little bit of numbers today. And we'll do some practice during class. Cool. All right, scientific notation. Again, I don't know if this is review. I'm going to go over it so that we're all on the same page and the expectation is very, very clear about what you need to know. So you want to understand how to convert very large and very small numbers to scientific notation. And then if you see a number in scientific notation, you should be able to convert it out of scientific notation, which is standard notation. And again, standard notation is just a reported measurement or number that shows all place values in its expanded and true form. So if you are dealing with a number that is in the millions, if you write it out with commas, how we normally write out numbers, that is standard notation. Or if your number is really small and it has decimals like 0.00000000001, that is standard notation. But sometimes that takes a long time to write out. And especially if you're putting something into your calculator, it's really easy to make mistakes. So there is a shorthand way that we can write very large and very small numbers. That is scientific notation. And I know you guys know what this is. It's basically a number times 10 to an exponent. And the definition is it's a shorthand method for reporting very large and very small numbers and measurements. I say measurements because a lot of the times when we deal with numbers in science, we're reporting measurements or we're analyzing data. And it's important to know how scientific notation plays into that, especially if I just give you numbers in scientific notation. My expectation is that you know what that is and what that means and how to either put it into your calculator, which we can do together in class, or that you take it out of scientific notation if that's easier for you. The 3 parts of scientific notation, and I think I have a photo here. So we have C times 10 to the n, and all 3 of these are a part, okay? We have the coefficient, the base, and the exponent. So the number one thing is the coefficient, and it must be greater than 1, but less than 10. If your number is less than 1 or greater than 10, it is impossible for that number to be in scientific notation. So this coefficient must be a number between 1 and 10, greater than 1, less than 10. And it is always a number immediately followed by a decimal point. I'm sorry, sometimes it is followed by a decimal point and further numbers, but sometimes that's not always the case, but generally it is. So that is C, which is the coefficient. Next, we have the base. The base is always 10. And this gives us the ability to round pretty easily and move our decimal pretty easily because we're multiplying it by 10 a certain amount of times, depending on how big the number is. And then finally, we have the exponent. This shows the number of places that the decimal is to be moved to the right or to the left. So if the exponent is negative, the decimal moves to the left. If the exponent is positive, the decimal moves to the right. And again, we're going to do a worksheet on this. I know you guys know how to do this. I know it's just a matter of counting the decimals, but why don't we run through an example and then you're going to do some informative here. So we have here, convert to scientific notation, and it gives us a number 919000000. So the first thing we want to do is find out what our coefficient's going to be. And it seems like these numbers would work well for our coefficient. Okay? And in order for this number to be a number between 1 and 10, we'd have to put a decimal point here. And now this number is between 1 and 10. But again, we have some trailing zeros. So we have 1 0, 2 zeros, 3 zeros, 4 zeros, 5 zeros, 6 zeros, 7 zeros. okay? So all I did was copy the number, but I made sure to put a decimal point between where my coefficient's going to be, okay? Now, in this problem, our decimal point is back here. When we convert it to scientific notation, we want to get it back to that number. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Okay. So if we have 9.19, we multiply that by 10, which is our base, and how many times we move the decimal. And we move the decimal to the right. So it's going to be 9.19 times 10 to the 9th. And again, pretty confident you should have seen this before. We're going to do some practice next time. If you don't know what this is, please do not be overwhelmed, because we have office hours and we have ways to catch you up. But if you can do the stuff that's on the formative, you're in pretty good shape. Cool, I'm gonna go ahead and clear this. And we can move on. Oh yeah, and that is our final answer, 9.19 times 10 to the 9th. Somebody said this in class before I recorded this, and I had to put it on the recorded lecture. If you finish fast, you'll have more time to talk. Sophia, if you're listening, this is for you. Also, this is my niece. I took this picture yesterday. She says hello. Her name is Charlotte. She's wonderful. So go ahead, take care, answer the questions on the formative, and look out for the next video on significant figures.